2 times 12 equals 16.
12,
24.
good. 12, 24. 2 times 12 equals 24. Everyone?
2 times 12 equals 24. 0 times 6 is 0.
Good.
1 times 11 equals 11. 0 times 10 equals 11.
You're not cursed. 14.
I don't remember the 10 for this one. I really need to figure it out.
28.
Hold on. The Foundations guide says that the tune for 14 is Canton Races.
1428. Canton races on. Alright. 2 times 14 equals 28.
2 times 14 equals 28.
Everyone, 2 times 14 equals 28.
1 times 12 is 12.
Emma.
8 times 2 equals 16. 2 times 13 equals 6.
What's 2 times 1?
26.
What is it?
26.
Good. 2 times 13 equals 26.
2 times 13
Alright, Mason?
0 times 11 is 0.
Good. Libby?
8 times 0 times 8 is 0.
Taylor?
1 times 5 equals 5.
Speed round. How fast can you go?
1 times 6 equals 6. 8.
Whole thing.
2
6 times.
times 8 equals
2 times.
2 times 4 is 8. 1 times 10 is 10. 0 times 12 equals 0. 8 times 1 equals 16.
No, 8 times 1.
8 times 8. 1 times 8?
Yes.
1 times 8 equals 8. 1 times 4 is 4.
Good.
0 times 15 is 15. 0.
0 groups of 15.
1 times 13 equals 13. 2 times 3 equals 1 times 2 is 2. 2 times 10 is 20. 2 times 2 equals 4. 1 times 9 equals 9. 5 times 2 times 5 is 5. 10.
2 groups of 5 is 10. Can I have the pencil, please? Oh, hold on. This is
1 times 13. 15 is 15.
Good.
2 times 7 equals 14.
David?
0 times 4 equals 0.
Sorry, I have something to add. Mason?
7 times 0 times 7 is 0. 0 times 2 is 0. 0 times 5 equals 0. 2 times 11 equals 22. 7 times 1 times 7 is 7. 2 times 5 is 10. 0 times 13 equals 0. 1 times 3 equals 3. 0 times 9 is 0. 0 times 14 is 0. 2 times 6 equals 12.
good. Alright, our notations that we've been working on from last week and this week.
Just write on down.
What is this decimal point? It's called a decimal point. Yeah, it's called a radix point. It's decimal point base 10, but otherwise it's only base 1. What's David?
Plus.
These are 4 ways to show what function.
Look here. Multiplication. That's what
And group brackets.
Bracket.
Nope, these ones are curved. Parentheses. What is it?
Plus.
Or positive. D stands for.
Dimension.
Thank you. All right, everybody together. The square root of 2 equals approximately 1.414. David, do you remember what Q is? Which domain? Rationals? Rationals. Mason, do you remember what the U means? Universal set.
Universal set.
Universal set. Good. Complement. Good job.
Complex.
Complex domain. Which domain is this? Starts with N. Just don't do that. Leave the handle alone. Mason, this is a Roman numeral. What is it? How many is it?
I don't know.
Roman numeral
5.
5. Good. What letter does it look like? E. E for element.
Equals. Infinity.
Not infinity. Ellipses. Means a continuing pattern, right? All right. New ones for today are going to be some that we saw yesterday. This is a subset. Which way is it going? It's got an opening on the right-hand side, right? It looks like it's a backward C. This, nope, that's a regular C. This one is a backward C. The opening's on the left. It's a superset. So subset, superset. Okay. What's this one?
Intersection.
Intersection. The rainbow means intersection. It connects this point to this point, right? Intersection. What's this one?
Subset.
Subset.
Intersection.
Intersection. What's this one?
Negation.
Negation means not or opposite.
Not.
Negation. What's this one? Intersection.
Subset.
Subset. Mason.
Intersection.
Negation. I thought we pulled this one out. Okay. And superset or equal.
Superset or equal.
So, and then this one is subset or equal. So look, we have subset, subset or equal. All right, same form. Subset. Good. What is this one?
Intersection.
Good. What's this one?
Negation.
Negation. Not.
Subset or equal.
So remember when you have your where'd the element one go? Oh, that was from yeah. So remember when we do when we show from yesterday when we were doing our A is an element of set B. Remember when we were doing that? And then sometimes we said A is not a subset of B. This is the not. That's what we're adding, right? To show negation. It's not. All right. Go ahead and open to page 9, grade 3. Mark flashcards. Is that all the ones that we're adding for notation system?
Yes, ma'am. So tomorrow says, you said I2 multiple.
We looked at I2 yesterday. Let's just go ahead and go to page 9.
No.
All right. You do what you can and I'll help you after. Yep. We're going to trace our first dots, tops left. And what does that say? Anybody want to read that? Or do you want me to? Anything to the 0 power equals 1. We're over here, Mason. Anything, that's the long word you're tracing, to the 0 power, so our indices is going to show 0, equals 1. What else equals 1? What's that Unity equals 1, right? Unity is when we have a group, but they all come together. Unity. Okay, so if anything to the 0 power equals 1, then what is 43 to the 0 power equal to? Yep. And what is 15 to the 0 power equal to? 1. All right. On this top row, you have your integers. And on the bottom row, they want you to write the natural domain equivalent. So we know in integers, we have what kind of numbers? What is the symbol? Negative. Right. So in natural domain, do we have negative numbers? No. So we're doing the opposite, or the natural domain of the integer that's not.
-6, negative.
We'll pause. Are those integers or naturals? If it's negative, is it an integer or a natural?
Integer.
It's an integer. So we want to, here we see -1 is an integer, and the natural equivalent is +1. So if -3 is the integer, then what's the natural domain? 3. Just +3. And if -5 is the integer, you don't have to write the positive. If you don't write a symbol, it's assumed positive. The opposite, or the natural domain number for the integer -5 is just 5. Naturals also include the digits domain. All right, on this next row, we're going to trace our integers. I want you to read. Yeah, what is digit?
500.
It is.
This is, I'm going to say it's 500. No.
Not quite. All right, on the top line, trace the integers. Read me the numbers out loud.
100. Positive
100.
100. 100. Positive 125.
David, wait a minute. Let somebody else have a turn. What's the next one? Mason.
Negative.
How many hundreds?
Negative 1.
150. Yeah, -150.
50. And
Libby, what's that last number?
positive 550. What? 500.
Positive 500. Good. Trace your Roman numerals that equal those same numbers.
100 is C.
Mm-hmm.
525 is CXXB. And then there's D. And 150 is CL. And D is 500.
Very good. And do we have tally marks today?
Yes.
It says trace, and then count from 6 to write the missing tally marks all the way up to 11. So you're tracing 6, and then you're tracing 7, but then 8, 9, and 10 need you to fill in the tally marks that are missing.
Is that 6?
Yep. So we have different 6, 7, 8. Yeah.
10.
Let me see your 10. How do we do a group of 5? We do 1, 2, 3, 4, cross.
1, 2, 3, 4, cross. 1, 2, 3, 4, all these different cross.
You see here, do 1, 2, 3, 4, 5 cross. So let's erase that extra one. 1, 2, 3, 4 cross. And then how many do we have on the last? Should be 1, 2, 3, 4. So you have 6, 7, and then you started at 6 again. What comes after 7? No, you're right. You just need to add one. 5, 6, 7. Wait, this is 7. What should this number? 6, 7, 8. Then 9. Then 10. What do you need?
What are these?
Okay, so these are groups of mathematical symbols. The first one means sum. This middle one means pi. And the one on the far right means phi. The instruction says circle groups of 5. So in each, they're technically Greek letters. In each Greek letter, circle a group of 5. So circle 5 some. Then circle 5 pi.
Now I want.
Then circle 5 phi.
Now I want pie.
It says color the squares. So color how many it shows you to color. Pay attention, color neatly.
So I color off only 10.
Only 10 out of that 100 block. Alright, how many do you color on this next 100 block?
15.
Not 15, 50. Remember we talked about our place value yesterday? In base 10, what's on the left of the radix point? Do you remember from yesterday? In base 10, the
Place
left
value.
place value is what we're talking about, but on the left, do we have parts or wholes? Ayla. On the left, do we have parts or holes?
A hole.
To the left of the radix point, we have our holes. To the right, we have our parts. So if we had 1, 2, 3, how many groups or how many digits are in our, what did they call those? They were sets. Well, let's start choosing the two ones.
Now I color.
You don't have to shake the table. Periods. Okay, so each of these groups is called a period. That's from solutions for
Guys, stop
page 3
shaking.
in monomials. Each of these are periods. They're separated by commas, yes?
Yes.
Yes. What is this place value called? Libby, what place is this number in?
Mommy, what's Mason.
No, this is the digit 9, but when we're talking about place value, is this ones, tens, hundreds? What place is this? So this is,
No.
it's a ones place. Ones place. Okay, what comes after the ones place? Yes, tens place. We talked about this yesterday. What comes after tens? Ones, tens. Hey, y'all need to stop talking ugly to each other and focus on doing your work. I'm sorry that this table shakes, but you will survive one day.
No, Mason's not doing one color for all of it. He's doing two.
I don't mind if you use different colors as long as it's on different problems. We don't need rainbows in one problem. That's going to get confusing. Mason.
I didn't do
You did though, because this is the same problem. All right, let's look at the next page, please. At the top of the page, we have a domino. Can you trace the domino? And Mason, what coins do we have in that
penny.
group? We have pennies and what's the other coin?
A nickel.
A nickel. How much is a nickel worth? 5 what? 5 cents. How much is a penny worth?
1 cent.
1 cent. So 5 cents plus 4 cents equals how many cents altogether? 9 cents. Finish tracing
Do we
that
color nine?
row. Yes, you trace the domino and you color all the dots. And then you trace the numeral.
Do we color all the dots or one missing? Do we color all of them? I thought we colored 9 because.
You do color 9. That's 5 plus 4. That's 9. And then you trace the number, the numeral, and then you trace the word, and then the Roman numerals, and then the tallies.
So that's 4 ways you
Mason,
can.
it's not moving the table.
That's 4 ways you can do that.
That is. Go ahead and do 10 next. Okay. When we get past the hundreds period, David, we have ones,
Then 2,000.
Not 2,000.
Then 10,000.
10,000.
I do one.
Yes, give me 1 second.
Did it.
Right, Mason.
And a billion.
Mason. Ones, tens, hundreds, thousands, 10,000s. What place is this?
4.
See, we have our group.
100,000.
Yeah, we have groups of threes for a period. They're separated by commas. And we go ones, tens, hundreds, ones, tens, hundreds, ones, tens, hundreds.
I know what's next.
What's
Millions. Billions. And trillions.
not yet. Billions. So look at this, Mason. If we have millions,
Millions.
then we have
Trillions.
10 millions.
Then we have billions.
Then we have 100 million. Then we would have a comma, and this one would be
Billions.
billions. So go ahead and look at, is it chart 3 this week?
No, I'm not done. I'm done.
Okay. Let's turn to, are you using it? Yeah, chart 3. So look right here. We have, Mason, we're not tearing it out right now. Okay, so here you have ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, 10 billions, 100 billions, trillions, 10 trillions, 100 trillions. What comes after a trillion?
So long. Shoelaces.
I think it's zillion. I'm not sure.
Then
But it gets bigger and bigger and bigger. And what groupings are base 10 numbers in? Our whole numbers are groupings in what? Of what? How many digits? How many digits is this? 1, 2, 3, comma. 1, 2, 3, comma. So our whole numbers are in groups of 3. But then when we hit the decimal and we go farther right, he's not trying to, David. Okay, but you're leaning on it and that is shaking it. Okay. Right of the radix point or the decimal is partial numbers. All right, we'll get to that later. Go back to your worksheet and we are matching. A couple means 2. Where do we see 2? 2 terms. The dollars. Yeah. A couple is 2. That's dollars. A dozen is 12. Good. Well, but that's already matched because it's a pair, right? That one's already been used, so we're not going to use it again. A few is 3. That's right. Yep. And single is 1. Dozen is 12.
Is this our second page?
Ayla, do you remember, is this function? Do you remember that symbol? Okay. Mimi popped in and the dogs went nuts, so we paused. That symbol means indefinite integral. You say indefinite integral? Alright, so trace your numbers next to your 10 blocks. We'll add that one to our. And then let's talk about the symbols. That top symbol in the middle is called a radical. It's like a check mark box. Radical. What's the symbol under it? Do you know? This one? Percent. Mason, what's this one? Pi. Do you remember in our geometry what pi means? Rectangle equals length times width. The area of a square equals length of its side Celsius, we use Fahrenheit. Trace the F. Why are you not tracing? Fahrenheit, and then scientifically we use Kelvin. What do you notice that's different about Kelvin? It is a K, but this is, it doesn't have the circle. That circle is called a degree symbol. But Kelvin doesn't use a degree symbol. You just label it with a K. All right, repeating decimal. It says write the repeating decimal under the vernaculum twice. So see this little line right here? That's called a vernaculum. That means that number is repeating. So you see 5.22222. It would just keep going, keep repeating. Here you have 5.21. So you see the repeating is 5.2121221, right? Here on this third one though, we have 5.02. Does the 0 have the vernaculum?
No. So it's
Vernaculum under it?
5022.
Yeah, so only the 2 is repeating. All right, you do that with the 4 and the 3. So look at 4.3. Which number is repeating? Look here. So you're going to do, if it's 4.3 repeating, you're going to say that's about 4.3333. That's what you're writing in that length. Because that repeating symbol means that you're repeating the number underneath it over and over and over. Yep. Because that's the extension of what that repeating symbol is showing. Make sure your decimal is on the, make sure your radix point is on the bottom, because if it's up in the middle, that means multiply. The position of our symbols matters. All right, so the next one is 4.34, and the vernaculum's over 3/4. So what are we going to do with that? 4.3434. You can write 2 or 3, but that's what that repeating is, right? Okay, and then the last one is 4.03, but only the No. What digit numeral is the line number? What is it on top of? It's only on top of the 3. So what is the only thing that repeats?
4, just 3.
Just 3. The only thing we repeat is the one with the vernaculum over it.
Can we turn the page?
Alright, anything to the 0 power equals?
1.
1. Trace it. Or match it.
Anything to...
The first power is the identity. It equals itself. So it's 3 to the first power equals 3. Which set shows 3? Yep.
The second power.
Means 3 times 3. So here you have 3 rows and, 3 columns and 3 rows. So match that one. Alright, the next instruction says, yep, just straight down. It's 3 groups of 3. 1 group of 3, 2 groups of 3, 3 groups of 3. How many is that?
2.
9. 3 squared, or 3 to the second power, is the same as 3 times 3, which equals 9. Alright, this next one we have copy the scientific notation, so you're literally just copying what they already wrote. They wrote 400 equals 4.0. We're up here, Betty. And times 10 squared. So that's what you're copying.
And this, recopying this one, this.
Yep. No, baby, they already have the equal sign, and we're not writing it over here. We're going to write it exactly underneath what they already have. 400 equals what? Make sure your point is on the bottom and it's not floating in the middle.
Is that where it's supposed to be?
Yes, but this one looks colorful. talking about our prefixes. Tear and try mean what? Three. So ternary, there we go. Ternary uses 3 digits. What are those digits?
0, 1, 2.
Good.
0, 1, 2, 0, 1, 2.
Good. Now you're going to be writing the place value. So look at your tens bars and count how many tens bars there are. 4 groups of 10.
1, 2.
Good job remembering your index.
8.
Go ahead and do that in your head because not everybody's quite there yet.
What?
Ternary uses 3 digits. 0, 1, 2, 0, 1, 2. Trace that for me. Libby, go ahead and do it at the bottom. Count your place value sections and then add them all together.
Do I
Yes.
write hundreds?
How many hundreds are there?
5.
5.
Alright, 5.
Yes. How many tens are there?
4.
5.
How many ones are there?
No, there's 4.
How many ones are there?
Count in your head.
1,
2, 3, 4, 5. You're right. 5. Sorry. And how many ones?
9.
So now, if we put, how many hundreds do we have? Let's keep our place value. How many hundreds? Look at your page. How many hundreds did you just
5.
count? We have 5, and we're going to keep that in the hundreds place. How many tens?
5.
5 in the tens place, and how many ones?
9.
9. So we would keep our,
549.
we're going to put our digits in their correct place, and that's our total. Write your total after the equal sign.
Done.
Right?
Skip
Skip,
4.
skip counter 4 is point as we say.
4,
4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, and 16. Good. Can you write your total that we wrote on orange up on the board? 12. We have to do 12. Yeah, that'll be done. Go ahead and trace.
Did you use the numbers at the very end?
You're right. That is a little bit different today.
That's all
isn't
we've
it?
done.
9, 10, 11, 12. All right, trace. This is the sentence written out. This is the sentence written in mathematical notation.
Mom.
Yes, sir.
FA said that you can turn an F into an A.
Interesting. Yeah, I see that. That's kind of work. All right, trace your sentences, please. Yes, you are done. Can you read that top one for me? Yes. Negative. What does that symbol mean? Do you remember? The E symbol means element. So negative 18 is an element of set A. Yeah, negative 18 is an element of set A. Mason, read that second sentence for me. What number is this?
Negative 4
Is an element
is the element B.
of set B. Okay, David, can you read the last one?
6 is not an element of set A.
Good. All right, match your sets in this section right here. Match your sets. So this is, the U means union. So this means which one has 1 This is 1, 2, and 3 on this side. Which one is 1, 2, and 3 on the right? Yes.
This one, Mom.
Yes. And then what is the last set? We have 1, 2, and negative 4.
Would it be this one?
Yes. And then this is good. All right. Trace and match your sets. Right here.
They're right here.
All right, the next instructions say match the elements. So you're gonna match the elements from the first set to the second set.
It says.
Do all of the first section before you move on to the next section.
It says.
See these lines right here that separate? So that means it's a new problem.
It says
But look
negative.
here, 38, 54, 54, 67, 67. Because you see this line right here? That shows us that's one problem. This is one problem. So do everything in this section before you move to your next section. Good. And then the last thing is going to be our fractions. So you're going to trace your whole, separate it into the parts, and then color the parts that the fraction shows. Hold on a second. What is it, David?
It said negative 12. Positive 12. 12.
But the last one's not 12. What is this one? 21. So trace and color half. Trace the circle and divide it in half first, then color it. You can do different colors for the different problems, but don't change colors in the same problem. You need to trace it first.
Do we color half of it, Mom?
Yes, that equals what?
Do we color half of it? Well, one.
So you are coloring half of it, but it's showing that you color, how many parts is it broken into?
4.
And how many parts do you color? 2. And that's going to be the same as 1/2, right?
Should I color in one?
Okay, this is how the denominator tells us how many parts there are. The numerator tells us how many parts we have. So how many do you color in? 2. Yes.
He had 6, so we color in 2.
Very good. And do you see how even though the numbers are changing, you still have half, right? The pieces are getting smaller, so you need more of them to make the same amount, but you still have the same amount in the end, right? All right, so this first fraction is 1/2. Can you say that?
1/2.
The second fraction is 2/4, and the third fraction is 3/6. Good. All right, if you're done with that, go ahead and put your stuff up. You're done for today. Thank you.
You are welcome.
Finish?
I did finish.
I wasn't talking to you, silly.